All right, hi students. So if you're not here, or if you were here and you just want to watch this to see what you might have forgotten or missed during class period, especially those of you who like to wander out and go to the bathroom every day and miss some of the instruction and things that we go over. Okay, so we have a test tomorrow over Chapter 4. Learn Smart 4 is due by the end of the day tomorrow, 2:30, by 2:30 tomorrow. Running the reports at 2:30. If you don't have it done, I'm not interested in even giving you a late grade. So whatever you have done at 2:30 is the grade you get. Because once we take the test, it is no longer important that you do the practice test, which is what Learn Smart is. It's practice test questions, practicing the material with the test question type formats. So, all right, so I told all the students in class the following information. I told them that the test was 35 questions, 5 points apiece. There will be true, false, there will be matching, there will be multiple choice. Over Chapter 4, lessons 1, 2, and 3. Those are the 3 lessons. All right, so the matching, I gave them what would be on the matching. In the matching, you are matching the term electron to what an electron is. So it could give you, it could tell you the charge, it could tell you the location. You need to know everything about an electron. Nucleus, you need to know about the nucleus. These terms, actually a lot of these terms, you've had since January, so you ought to be perfect at them. We just tweak them when we get to different parts as to how we use them. Now we're talking about how they're needed for bonds. So, electron. Nucleus is another term that is in the matching part. Ionic bond. Covalent bond. Polar molecule. Compound. Chemical symbol. Chemical formula. Molecule. And subscript. Then we looked at, for example, this equation that's on the board behind me. This was a possibility of an ionic compound you could have created on the mini lab activity that you did. So beryllium is in group 2. It's a metal. And oxygen is in group 16, and it's a nonmetal. So ionic bonds are between metal to nonmetal. Metals give away electrons. When you give away negative charges, you're no longer neutral, you're a positive charge, depending on how many you gave away. If you gave away 1, you're a positive 1. If you give away 2, like beryllium does, you're a positive 2 after you give away 2, because now your positive protons outnumber your negative neutrons by 2. Negative electrons. Did I say neutrons? Negative electrons. Because you were a neutral atom. So I start out neutral, I gave away 1, I become positive 1. I start out neutral, I give away 2 electrons, I now have a positive 2 charge. Okay. Your oxygen is your nonmetal. They become negative because they took in negative electrons. And that's what the red dots were showing you. The oxygen took those 2 red dots from the beryllium to make it have an octet. Okay? This makes an attraction between positive and negative. And it's perfect because it's a positive 2 and a negative 2. So it's a perfect attraction, just like a magnet. Just like the video told you. Just like I told you. Right? All right. So you have to understand that metals become positive ions and nonmetals become negative ions, and there's an attraction, and that's how you get an ionic bond. That's a review. But it's also stuff that's on the test. Valence electrons are the electrons that are responsible for bonds, and your dot diagrams are the valence electrons, the outermost electrons. So group 1 has 1 valence electron, group 2 has 2 valence electrons. Group 3, we skip, because that's transitions 3 through 12. Group 13 has 3. Group 14 has 4. Group 15, 16, 17, 18, octet, they're stable. The goal is to have 8. See? Oxygen ended up with 8. Very happy. And actually, the beryllium, the ring before the outer ring that gave away 2 electrons, now it is stable. Yeah, so the goal is an 8 to make it chemically stable. The dots represent valence electrons. So we went over that. Page 140, there's a table on that page. It takes up almost the whole page, and I kept telling you guys, when you read through these, you need to look at the tables. Look at that table, because one of the diagrams in that table is on your test, and you have to identify what it's a diagram of. So look at that table. The 3 types of bonds are covalent, which are nonmetal to nonmetal. So the way you have to know that, you have to know it's nonmetal to nonmetal, but you also have to be able to apply it. So if I give you an example, I have a compound, H2O. What kind of bond is it? Well, you just have to look at hydrogen is a nonmetal, oxygen is a nonmetal, therefore H2O is a nonmetal to a nonmetal, that's covalent. I've had you write those at least 3, if not 4 times. We've had bell work, we've had concept mapping to clear that up. Covalent is nonmetal to nonmetal. Ionic is metal to nonmetal. Metallic is metal to metal, hence metallic. It's all metals, right? Those are all on there. When it comes to reading H2O, it's 2 parts hydrogen. Know that the subscript goes with the symbol before it. So there are some questions like, for example, if I was asking you a question about this formula, chemical formula, I might say, how many hydrogen atoms are in H2O? And you would say 2. Or I might say, how many oxygen atoms are in the formula H2O? You would say 1. There's only 1 oxygen. Okay? So you have to know where the subscript goes. What if I said, what kind of bond makes table salt? Well, what's table salt? We've been talking about that now for 4 weeks, maybe. Sodium chloride, NaCl, and it was in, I think, 2 different videos, NaCl, maybe 3. Those short videos. NaCl, sodium chloride. Sodium is a salt. Sodium is a metal. Chlorine is a gas, which is a nonmetal. Metal to nonmetal is ionic, because there's the transfer of electrons. They move from the metal to the nonmetal. That's how they do that. Make sure that you read the true-false questions carefully. You just have to read them carefully. Remember that the electrons closest to the nucleus have the least amount of energy, and as you move away from the nucleus, it has to travel further, and so they have to have more energy. Okay. There's connected.mcgraw-hill.com is where you'll find LearnSmart. Okay. Reach out to me if you have any specific questions. that you need, or topics or concepts that you need help with for Chapter 4. Chapter 4 was about electrons and energy levels. That's where we find the electrons. Electrons are negatively charged, and they are responsible for chemical bonding, specifically valence electrons. Okay, what kinds of bonds? Covalent, ionic, metallic. Those are the possible kinds of bonds. All right, look on the test. Oh, polar molecules. You need to know polar molecules. In the water molecule, I told you, I gave you notes, and I wrote a thing on the board as to why the polar molecule has a slightly negative and a slightly positive. So you need to know where the slightly negative is located in a water molecule and where the slightly positive charge is. Hydrogen is one and oxygen is one. So who's who? So if you don't remember that, check your notes, because we've said that more than once. All right, get ready, study.